The following program is brought to you by Caltech.
Hello, I'm Jesse Chris. I work with Scott in the Human Interfaces group at JPL. I'm very excited to introduce our next speakers, Fernanda Villegas and Martin Wattenberg. I've had the pleasure of working with them in the past. We were working at IBM Research in the Visual Communication Lab, where we developed a website called Many Eyes, which was a web-based public site for creating and sharing visualizations and having narratives around that. Martin and Fernanda have done amazing work both before that and since. You've probably seen some of the things they've made. I'm sure they will talk about them today. But I'll just let you know that I think they're really some of the foremost thinkers in visualization as narrative. And they do as good a job as anybody at bridging the aesthetics, the human qualities, and the computational design for visualization. So please welcome Martin and Fernanda.
Okay, so our talk has such an interesting title because we thought we would talk about a range of projects today that go from scientific visualization all the way to art projects. And one sort of common thread running through all of these projects is this notion of complex data. We hear a lot about simplicity and the importance of keeping things simple. And yet what you're going to see here today is that whenever you're dealing with complex data, it's really to your advantage to embrace that complexity and to make it shine. And so one of the things to sort of keep in mind as we go from project to project is how we're trying to design techniques and ways in which we can tell the story of the data while embracing the richness and the texture of the data that we're dealing with.
So we'd like to start by talking about a project that's actually the first project the two of us worked on together. And we're going to take you way back about 10 years ago to 2003, and when Wikipedia was still just a new thing. And we want to give a demonstration of how you might use visualization to explore a system where you may not even know any specific questions. You just have a general one. So if you remember Wikipedia, we all are familiar today, but even back then, it was pretty good. And that was a huge surprise at that point because, back 10 years ago, an encyclopedia was something that like a council of wise elders wrote in some chamber somewhere and then handed down to school libraries all over the world. And yet here was something that anyone could edit, just by clicking a link. And it really felt strange that you would get, nice structured articles with tables of contents and beautiful pictures. And Fernanda and I just wanted to know how that could happen. How could that be true? We really had very little specific question other than that. What we did have was data, because for every article on Wikipedia, they kept a very extensive edit log of every edit that was made, what time it was made, exactly what changed, if there was a user who was logged in, what their username was, even a little comment. And all of that was publicly available. Either a friendly way you could download a special file from them, or you could just scrape it. Not that anyone would do that. So we took this data and we immediately realized it was an embarrassment of riches. It was too much. If you look at a bunch of different versions of the same exact essay with just like one word tweaked here or there, it's very hard to make sense of it. So being visualization people, we decided, okay, let's start turning this into pictures and see what we get. So we created this method we called history flow. And it's actually very, very simple. Let me sort of explain what's happening here. The idea is if you have a document that goes through multiple versions, we represent each version by a vertical line. The length of a line tells you how long the document is at that point. And then we color each section by the author of that section, because as in Wikipedia, we sort of know who wrote what. Now, already that's kind of interesting. You can start to see a little bit of the history there. But it's not the clearest thing in the world. So we added these connecting sort of polygons that say, OK, if a passage stays the same from one version to the next, we'll just connect it with a polygon. There's a lot of software diffing tools that will do this for 2 versions. And what we're doing is just extending that through multiple versions. So here, for example, on version 2, in blue, Suzanne edited some text at the end. From version 3 to version 4, what changed is Suzanne inserted a little piece of text in the middle. Everything else stayed the same. We can then go on to play a bunch of games with this. We can say, well, we can space these versions by real time rather than just giving them an equal spacing by version number. We can let you zoom in on a particular version and see the text and so forth. And really with that, we were ready to just sort of go exploring and see what we could see.
So let's see what History Flow looks like. And remember, this is History Flow and Wikipedia back in 2004. So this is the diagram for the article on design on Wikipedia. On the left here, we have the number of people, the different authors who have touched this article. On the right, we have the actual text of the article colored by the author color. I also have this wand that I can start to move back, and you can see how the text of the article is changing. So now, let's look at something a little bit more interesting. Let's look at cats, because the internet loves cats. As you can see, I have more people who care about cats than design. There are a lot more versions, and as I scroll down, it's a much longer article. And then there are interesting things, like there's this stripy pattern here at the top. And what's happening is, if you look at the article, you can see that someone came over and added a table where they talk about the kingdom, the class, the order, the family of cats. And then we have an interesting little antenna at the bottom. And I'm interested in this because it sort of doesn't go anywhere, so I want to know, what kind of content were people adding here. So if I bring my wand all the way down, I see that someone added a whole bunch of paragraphs in white that talk about the Unix command cat. I knew you would get the joke. So what happens then? Did someone just delete this whole thing? So if I go to the next version, I can see that no, they didn't just delete the whole thing. They created a new page called Cat Unix and redirected the entire content there. Okay, so these are some of the dynamics of collaboration that we were interested in. So let's look at another dynamic. So I'm going to bring up something a lot more controversial. I'm going to bring up abortion. So we have a huge article, but does anything on this diagram jump out as different? The gaps, exactly, right? So we have two big gashes here. And what happened here is I have this long article, and then boom, I have nothing. Or if I come here to the second gash, I have the article, then I have nothing except that abortion is great, and then the person came back and added abortion is good. And then it got fixed. But one of the things that we saw in the visualization is that if I go back to, okay, this is an act of vandalism. It's called a mass deletion. We all know that there is vandalism in Wikipedia. But one of the things that the visualization impressed upon us is that at the bottom, I have a timestamp for when this mass deletion took place. And it was on the 17th of December at 4:06. It got fixed on the same day at 4:07. So, and this is something that we kept seeing over and over again. These mass deletions would get fixed within minutes. And so we got in touch with Wikipedians and asked them, how are you doing this? What's the trick? And they told us about something called a watch list, which is, whenever you edit a page, you might want to add that page to your watch list. And every time that page gets edited, you get a notification saying, oh, someone edited abortion, for instance. And then what they do is if they recognize and trust the name of the person who made the edit, they don't even bother looking at it. But if it's a new IP address or an anonymous user or something, they go and check and make sure that it wasn't a vandal. So if I look at the same data, but I space things out by real time, I can in fact see that those gashings happened and were fixed so fast that they don't even show up here. Finally, I want to show you one of our favorite pages, which is obviously chocolate. And it's very pink, but it doesn't have anything specifically interesting, except that we're visualizing this in real time. And now I'm going to change to visualizing it by version. And then I get a pattern. that I thought was very beautiful, and I wanted a scarf that looked like this. But does anyone want to guess what that zigzag is? An argument, exactly, right? It's called an edit war. So people are fighting about whether or not a piece of content fits on this page, and I can show you what that is. So back here, this person, Daniel C. Boyer, added this white paragraph that reads, extremely rarely, melted chocolate has been used to make a kind of surrealist sculpture called coulage. So that survives for a long time. I mean, if you look at the stripe of white, it survives for a long time. And then someone says, removing Boyer invention. Well, Daniel comes back and says, reverting. Coulage is not a Boyer invention. Google search for coulage finds only Boyer. Reverting. Leave your humbug out. Reverting. And so on and so forth. Until Daniel C. Boyer sort of gives up and whatever, which is too bad because Martin and I did a search for chocolate coulage and we did find that it does exist. But that's life on Wikipedia. The other thing we did is we were also interested in, if you didn't care about who wrote what, but you were just interested in the age of text, we started to color things by just how old the text was. So the darker a piece of text, the older it is. So if I scroll down the article, you can see that there's quite a lot of dark text here. And why do we care? We care because text that gets a chance to get old on Wikipedia can be thought of as a proxy for high quality text, right? If nobody's touching that text. And that is something that we found in a lot of articles, that there was quite a lot of text. But bringing this back to this whole notion of, big data, exploratory tools, data visualization, one of the things that Martin touched on before was we didn't have a very specific question when we created this data visualization. In fact, we didn't even know if any of the patterns we would see would make any sense. Nobody had ever visualized Wikipedia before. This was the first time. But then one of the things that happened really quickly was the fact that we started seeing we were able to see so many data points at the same time that certain anomalies jumped out at us right away, just like they did at you. Think about what just happened. We explained how the visualization worked, and I was asking you questions about what you thought looked weird in these diagrams, right? So this is exactly one of the things that complex visualization that is very rich will get you, is you don't even know how to articulate it very well, but you start creating this mental model about what is normal and what sort of is abnormal in the given space you're looking at.
Yeah, and it's interesting because you begin maybe in a generalized way without a question, as we did, but just out of curiosity. And then just as Fernanda said, you start to see patterns and then the questions come. And by the end, we found ourselves doing database queries to figure out, okay, if the article decreases in length by 90%, how long before it goes back to its original length, so it's restored? What if it decreases by 90% and the new edit contains the word fuck? And it's like these things actually turned out to be kind of important scientifically, and they're the very concrete questions that then go into sort of a scientific paper. There is a second aspect of this process that I want to emphasize as well, which is that in addition to being a purely scientific tool, these images that we created were embraced by people on Wikipedia themselves. I saw several cases where they would put them on blogs or even blow them up in very, very large poster format to talk about Wikipedia. And that talking, I think, was just as important a byproduct or product of this visualization as anything else. And many times Fernanda and I and people at our group at IBM started to see this, that when you have a visualization, it can tell you things, it can communicate information to you, but just as important, it becomes a way for people to talk to each other about data. So that led to a project that Jesse mentioned. He was the sort of tech lead on it, called Many Eyes. And the idea behind Many Eyes was to create a site where anyone could go, they could upload their own data, they could then visualize their data in ways that previously would have been very, very difficult. You know, our goal is to go beyond the things that just Excel offered. And then they could view and discuss the data with other people. And we'd like to take you through some examples of what you could do on Many Eyes and describe sort of what we saw there. So the site itself was, you know, something, it looked like this. You could still go there. It's sort of like, you could think of it as YouTube for data or Flickr for data in some sense. It's, you know, got a nice gallery of visualizations people have made. And in fact, you could browse visualizations, and there are many, many, you know, tens of thousands of visualizations that were created. In fact, it continues to grow at a pretty good clip, even 6 years later. And so this was sort of a shot on a typical day, and you could see the kinds of things that people were visualizing. It really, you know, all sorts of things. You know, people's music, you know, whether you're, you know, a lot of people like music. There's prisoners. There's Facebook data, of course. Really, there's a great diversity of things. Now, if you went to a particular visualization, you'd see something like this, that there'd be a standard visualization created at the top, but it would be a little bit like a blog in the sense that anyone could comment on this visualization at any point. And in fact, we got some pretty interesting conversations happening. Overall, there were, you know, many, many different types of visualizations. There's sort of more than we can show now, but I think it would be worth actually demoing some of the text visualizations and some of the things that people created that were a little bit more off the beaten path.
Yeah. So let's go to Many Eyes now. Let me bring this over. Oh, that's weird. It's getting, oh, no, that's okay. All right, so this is what the front page looks like today. This is a tree map. And a tree map was something that we weren't sure we would put up on the site even when we launched it, because tree maps felt very academic to us, and they felt like they were too complicated for regular lay users to use. But we're like, oh, what the heck? Let's give it a try. Let's see if people end up using it. And in fact, people did use tree maps. This is just a first one where we're looking at different car models, and it's the city versus highway mileage difference. So the better our car does on the highway versus city, the bluer it gets. Each one of these little rectangles is a car model. And if I mouse over, you can see that, you know, each one of them is a different car. One of the things we did, because again, we were aiming this at lay users, the idea was really to bring this to people who don't want to program, they don't know how to program, but they have data they might want to look at. A tree map is a hierarchical visualization. So you can see that not only do I have car models there, but they are clustered by, in this case, the class of the car. So I have compact cars, I have two-seaters, pickup trucks, and so forth. One of the things we did to make life easy for users was to sort of show the hierarchy of things here at the top, and then allow you to change on the fly the way this tree map is arranged based on the hierarchy that you care about at the moment. So for instance, I can bring manufacturer up all the way to the top, and then I have the cars arranged by manufacturer. Now, one of the things that's interesting here is that, like I said, the better your car does on the highway versus city, the bluer it is, which means that there are a few cars that are doing better in the city than on the highway because they are orange. And this is one of the things that people were fascinated by in this data set. It turns out that if I bring up transmission all the way to the top, I have all of my outliers clustered here. And if I mouse over, I can see that these are hybrid cars. So I have, you know, a Ford here, I have a Lexus that is a hybrid. So these are cars that not only are hybrids, but have a specific transmission to them. And that's, you know, there's a lot of discussion if you scroll down talking about this here on this visualization. Now, because Many Eyes is a public website and anyone can upload data, you get things like this, where someone created a tree map of their wedding. And you just gotta love this because, again, we were wondering, do people get tree maps or not. So this is someone who created a very specific, very complicated spreadsheet of their wedding. Each rectangle there is a guest. And they are visualizing the guests by whether they said, yes, I'm coming to your wedding, or no, I'm not coming to your wedding, in green. And then at the bottom, maybes and drinks only. And then you can see that there's a lot of detail. So I'll bring up to the top of the hierarchy main category of guests. So I bring this up. And then I have bride's friends and groom family and the wedding party. And you can see it's quite a well-balanced wedding here. There's country, so I'm going to bring up country all the way to the top. And I can see it's a USA and UK wedding. So it's an international affair with some of Italy and Australia down here. And then my favorite one, which is age, I'm going to bring all the way to the top. And I have young people or old people. I have no idea what the threshold is or where I would be there, but anyway, it's quite a diverse data set. But one of the things that was interesting is that people started uploading data sets like these, which are personal data sets. This person did it in an incredibly smart way, because even though they're being incredibly detailed about their wedding, I have no idea who they are. And they created this incredibly interactive visualization about something that's highly, highly personal. As Martin was saying, we did a whole bunch of text visualization. It turns out that when we launched Many Eyes, one of the first things we saw was that people wanted to visualize text. And we had no good ways of doing that except for your regular tag cloud or word cloud. So we created a couple of techniques for visualizing text. So this is what we call a word tree. And this is the word tree, a word tree showing the King James Bible, even though it's misspelled at the top. But that's OK. That's Many Eyes. That's a public website for you. And what it's doing is we did a search. And it shows you everything on the Bible that matches that search you did. And then it does sort of a suffix tree after that. So it shows you everything that came after holy space, comma. And if I do, let's say, and God, I have a very different tree there, and I can see everything that God, for instance, said. So what did God say? And God said, let there be light. Or what did God see? And God saw that it was good, and so forth. And then you can do fun things too, like I can put a question mark and put that at the end, and I have all the questions in the Bible. So I can see what is being asked of me, unto me, and so forth. So one of the things that was important to us was to create a visualization that would give you a sort of overview of the text very quickly, but without taking it out of context, which is what word clouds do, right? They sort of take away the context for the words. And so this is one of the things that the word tree prevents from happening. Again, because this is Many Eyes and people are extremely creative with the kinds of data that they upload, this is a visualization of personals ads of men who are married. And they say so on the personal ad. So they say, you know, I am married. And the fun thing here and talk about data analysis, right? My favorite bit here is the fact that you have two philosophies going on. I am married and looking, or I am married but looking, right? So you get a sense of the different ways in which people think.
OK, so we want to show one more text visualization. And I think it's a good illustration of how you can take, I won't even say big data, but medium data, and apply an incredibly simple filter to it. And just by virtue of having enough data, you actually get surprisingly meaningful results from something very simple. So this is a slightly tricky thing to explain, so bear with me. as I explain it, but it's interesting, I promise. So this is something called a PhraseNet, and the idea behind it is that you have a text. It could be a book, for example, and we want to get at the relationship between things that are mentioned in the text. And so we begin with a particular filter where we pick out a connector word, or a way of connecting two things. Here it's and. This is not a Boolean and, but it's just signifying that we're looking for two words that are mentioned going one and another. So for example, if we had the phrase pride and impertinence showing up in our text, we would create a graph where pride is a node, impertinence is a node, and the two are connected, okay? So we just create a little graph like that. And then we just do this every time we have a phrase of one word and another word. All the words that match end up as nodes. When they're connected by an and, we put an arrow between them, okay? And we can do this with other words than and, but let's just see what happens when we do that. So if we take Pride and Prejudice and, in fact, apply this thing where we're looking for X and Y, it turns out you get this very interesting network that kind of shows you a lot of the key concepts clustered correctly. So on the lower right, for instance, you can see a whole bunch of the characters in the book just popping up in their own area. If we zoom in on some of these other clusters, it turns out there's another cluster that just gets you all of the sort of emotions, so slightly judgmental. And you can see, pride and vanity, wishes and affection, amusement. It's this sort of interesting view of the world right there in this graph. Or if we do the word at instead of and, we suddenly get a network of what was happening where. So, all of these places, Pemberley, Longbourn, and so forth, Netherfield, these are locations, and we can sort of see exactly how these locations relate, to actions and people and so forth. We can sort of see all the, people and feelings that assembled at Longbourn here, for example. There's no sort of semantic analysis at all. This is purely sort of surface pattern matching, and we still get this very interesting, meaningful network. It turns out, speaking of the sense of play, you can do this in other ways. So for the Bible, we tried doing X begat Y, and you sort of get this almost correct, genealogy chart. It does have its occasional loop because of people having the same names and some ambiguous passages and so forth. But nonetheless, just with that one little filter, bang, you can get it. You can also use this as a way of comparing more than one text. So, for example, suppose you do X of Y. One of these is the New Testament, one is the Old Testament. You get a sense of sort of ownership and genealogy in each of these, very, very different feelings. Again, I think the lesson here is that even very simple things applied to enough text or enough data will actually give you very sort of interesting results that can be quite meaty.
And so to talk a little bit about how people were using Many Eyes, just one very quick example. 2 days after we launched the website, a user named Crossway uploaded a co-occurrence data set of biblical figures. So in other words, this person took every verse of the Bible, and whenever two people showed up in the same verse, that became a data point, okay? Then he created a social network of the New Testament, and you can imagine who the big dot is in the middle. He then went back to his website, to his blog, and blogged about it, and immediately started getting hundreds of comments on the visualizations. In fact, in a couple of days, this sort of started circulating beyond the Christian blogosphere and ended up in places like Boing Boing. And there's a screenshot there of YouTube where someone was, sort of just recording themselves playing with the visualization and what questions and hypotheses they had about the network. In turn, what this caused was to inspire other people who had data about the Bible to upload their data to Many Eyes, create visualizations, and bring them back to their blogs. And this is something that we could only dream about when we first launched Many Eyes, but it's actually sort of a textbook example of something that we hoped would happen, which is people who have data, some community who has data, taking advantage of this technology to sort of charge the conversation and their analysis, take it back to their own community, their blogs in this case, talk about it, get other people to upload data, and discuss facts and figures in that way.
So in many ways, this kind of confirmed some of our hypotheses, that visualization could be very social, it could be very generative, people can sort of bring new ideas and data to the discussion. One thing that we had not expected is that the role of the internet as a whole in this, it's not like all the action took place on Many Eyes itself, but instead it was important that it was part of this whole general matrix of ideas traveling around the net. And in fact, we've since then, I think, become increasingly interested in the spread of memes, the spread of ideas. How does information flow through a network? When we got to Google, we actually had a chance to visualize this data directly and embed it in a social network where the data was flowing. So we'd like to talk now about a more recent project called Ripples. You can find it today. Fernanda will show you how on Google+. And the interesting thing is that formally, it's very, very similar to something you saw earlier today when Jared was describing how an article will get tweeted by many people in Twitter. And we're really looking at the same kind of problem, that you can think of an information cascade where you have a few people posting about a given article. And then from each of those people can repost or reshare, as we say in Google+. Other people can reshare from them, and so forth. And so you get this giant set of trees, or even forest of trees, if there are many different initiators of conversation. And these can be very large. As in Google+, as in Twitter, it's not uncommon to have thousands and thousands of people sort of in the same conversation. And the question is, how do you display sort of the architecture of that conversation? And as always, this is the goal, not to do this. In any sort of social network visualization, there's always that looming hairball specter, that you have to avoid at all costs. And it's really difficult because the kinds of trees that you get, these information cascades, as you saw, are really big and complicated. Here's like one early attempt we did with anonymized data. And you can see that we had a tree that had very wide fan out, so you just can't really see very much. I mean, this was supposed to show things going from left to right, but very quickly you sort of run out of room to show detail vertically. It's also very hard, we tried other things. We made time the x-axis. That's actually can be very interesting, as you saw in Cascade, but we still ran into all these problems of overplotting. In the end, we decided, OK, we need to do something radically different. And I think it's interesting to compare approaches here. Jerwis sort of realized, we can go to a third dimension, and that's one way to gain more space. We thought, OK, what we'll do is take one of the standard space-filling visualizations that we sort of have in the visualization world and try to modify it so it looks like information flow. So here's the basic idea. Suppose we have abstractly a little tree, as you see on the left. So Steve would be the root node of this conversation. He would make the first move. Then 3 people would reshare from him. And from Mike, 2 more people would reshare. That's actually a very clear diagram. And if that's all we had to show, we would keep that as is. But for reasons you'll see in a moment, we're going to represent that in a slightly different way. We're going to use circles and containment. So Steve will get a very large circle. It's colored in with a color just for Steve. Everyone gets purple to indicate that he started that conversation. And everyone is inside his circle. Then you can see 3 curving arrows to the 3 people, Pruton, Rashid, and Mike, who reshared from him. And then Mike has his own big circle, and he gets 2 subcircles within that for the people who reshare through them. This is something called a circular tree map, but it has a bunch of little graphical flourishes to make it look like information flow. Now, you might, again, be looking at these and think the thing on the left is completely clear, but where this really starts to become powerful is when you have many, many, many different nodes. And at that point, this space-filling approach actually becomes extremely efficient and even starts to look like a little piece of information exploding out and shattering into a million pieces. So let's see what it looks like with real data.
OK, so let me switch now to Google+. This is what Google+ looks like. It's sort of getting occluded here. It's a stream, so I'm actually peeking into Martin's stream here. But one of the things it does.
Isn't that cute?
I thought you would like that, so I'm going to actually talk about this one. So at the bottom of each post, there are a couple of numbers. The one here on the left is how many people have +1'd this post. The one on the right is people who have shared this post. So, and whenever you have a post that has been publicly shared and people have publicly reshared that post, you get a ripple. So if I go down here, I can say view ripples for this post. And this is actually going to show me all the different ways in which, and there's one thing I want to do here. Let me reload this thing and make it smaller so that we can see the whole visualization. Yeah. So this is showing me all the different people who have reshared that particular picture you saw. The person I was clicking from was Colin, so I'm going to zoom into Colin. You can see that not only do I get people's names, but if they said anything, I actually see what they're saying about the post. I'm going to go back to my tree. So you can see that this tree, actually, this looks interesting. Let me go in here. There's quite a few levels of going in here. So you get a sense of how much of a relay sort of reshared from the friend, from the friend, from the friend. These things can get incredibly deep, as you can see. But so this is interesting and all, and you get a sense of the way the visualization works. I'm going to scroll down here, and you can see that at the bottom I have a timeline of the activity. It's quite bursty, and that's the way these things happen online. That's okay. But so far, you know, this is one tree. It's a single tree. There's a lot of activity there, but it's still one tree. But now let's look at something that actually went viral on Google+. So this is a much bigger graph. What I'm showing you here is the spread of a YouTube video called The Bark Side that Volkswagen created. It's an ad that they created for the Super Bowl. It's like a bunch of dogs barking the Star Wars theme. I can see a lot of people know what I'm talking about. So as you imagine, this became quite popular, and you know, I can see right away that this person, Chris Pirillo, is incredibly influential, has by far the biggest circle. Lots of his followers have reshared, and again, we start to get these more interesting resharing patterns here. He's not the only influential person. You can see some other big circles there too. One of the things I always find interesting, and let me see if I can do this for you right now, is to find out where Volkswagen is, because Volkswagen actually shared this content. Is this Volkswagen? No. They're very small. Yeah, they're here. So this is their tree. And I mean, they are the owners of this content, right? But this kind of graph, to me, quantifies exactly one of the things that we hear about a lot, but it's hard to measure, is the fact that on social platforms, a lot of times individuals have a lot more influence than official organizations. And you can see this pretty well here. Some of the other things we do is we keep some stats on the top influencers. We track the languages in which the content is being shared, so you get a sense of how distributed around the world these things are. So now, let me go back here and show you a few more examples. So this here is something that we're calling a celebrity pattern, and it's something that Jer, I think, sort of alluded to as well. It's the kind of graph where you have a main originator, in this case, Felicia Day. She happens to be a minor celebrity on Google+. She has a lot of followers. And what happened is she shared a link to a YouTube video, and then boom, immediately, a ton of her followers reshare, and that's it. It fizzles out. Okay, so we're calling this broad but shallow pattern, a celebrity pattern. Very different from something like this, where it's a distributed pattern. This is the sharing of the link to a petition to the White House for open science. And as you may imagine, there are a couple of organizations there that are very prominent. I also like to look at the bottom of the timeline here. You can see it was very bursty. It sort of died down. And then Tim O'Reilly comes up, and then boom, you have activity again, obviously because he's so incredibly influential. This here is different in that it's very special to Martin and I, because this is the ripples for one of our other visualizations. So we created a visualization, we're gonna talk about it, it's the wind map, and we posted on Google+. And we just sat there looking at this ripple build up over time. And this is what we call, using a visualization as a mirror. This was content that was ours, that we cared deeply about it. We are little specks there. You don't even see our names because we're not that influential on this social platform. But the cool thing for us was that we started looking at the people talking about the wind map and what they were saying, and we start noticing the different communities who were involved in this. So we had an air quality scientist talking about the visualization. We had a mathematician who had lots of followers. We had a very high up Google executive. We had a New York Times journalist. We had a comedian. Z Frank, anyone? Oh, I was like, Z Frank, you like visualization, that's awesome. So you start to get a sense, that's one of the things that is qualitative about visualization, is we could have sort of summarized a lot of this into a single number, and you would not get this qualitative exploration of the data. Not to mention that when you interact with this visualization, you're seeing the actual messages that people are posting together with the link. So again, this notion of using it to your own purposes, turning it on yourself as a mirror, can be incredibly powerful.
So what you've seen here is an exploration of the form of viral spread of ideas or memes or posts, but you're not seeing very much about the content yet. And the content actually is extremely interesting, and wondering how that thing spread sort of geographically as well as in this sort of abstract network world is also interesting. And so that leads us to our next project. This is something we did for YouTube. There's a project called YouTube Trends, where people at YouTube basically carefully look for which videos are suddenly taking off and among which demographics, which areas of the United States. And we worked with them to create a map of which videos were the hot videos, the hot new video all over the US. Fernando will show it in a moment. I will say, and this is where the Harlem Shake comes into play, that it turned out that many of the tricky things about this were not pure visualization, but really came down to data. And at one point, we found ourselves staring at a spreadsheet with roughly like 47 videos, and we had to kind of watch every single one and figure out, okay, which ones are spam and which ones are just really stupid Harlem Shake videos. And you learn a lot about humanity doing that. But that was the effect on us. More than anything else, I think, that this map shows you facts about the US that are very interesting.
And it tells you how much you sacrifice to do data visualization. So let me put this down a little bit. So this is the YouTube Trends map as it stands right now. So this is live data.
We wish there were prettier thumbnails today, but we're not in control of what video goes viral. So.
Every day. So let's see. The top video here is an official Call of Duty video. So it's sweeping the nation. The second top video is very localized. As you can imagine, this has to do with the hurricane, with the tornado in Oklahoma. One of the things you can do is you can, start playing the video right here if you want to. You can also see that we're breaking down the data by demographics. So we have everyone at the top, we have male versus female, and then we have things by age. So in fact, let me see if females look different. Yeah, good. See, so females are not all looking at Call of Duty videos. Yeah, right? But the males are. Okay. The other thing that is interesting about the Trends map is that these are the videos that are being shared, the top shared videos per region. We also, if you mouse over any given region, we show obviously the top video, but we show the second and third for that given region. But now you can also, let's look at what people are viewing instead of sharing. It's a very different map. So they are viewing My Last Days meets Zach Zoblek. I'm telling you, this is a way of getting on in the news. Like Martin and I have seen things you would not believe. And here's a Van Halen guitar cover.
Yeah, the north-south split is very dramatic here,
yeah.
I have to say.
Yeah. So, and the cool thing is that obviously the map changes every day. In fact, let me show you some of the historical trends. So this was the map a few days ago. Oh, this is what you just saw. And then this one was interesting. This was a couple of screenshots we took of male versus female about a week ago. So guys were watching a Superman video at the top there. Women were looking at a Dove Real Beauty commercial that came out. So you really get this split that is quite interesting. And sometimes certain videos that just sweep the nation. This is something to do with spear fishing. And again, because we're using the actual thumbnails to represent the videos, the map itself is going to look very different every day depending on exactly what the thumbnail is. And sometimes you're going to get these pretty gorgeous sweeps of color.
So we'd like to end with one more map of the US, and I think this one is very thematic because the data sort of comes from the US government, and you'll see in a moment how it applies. So the idea for this came on a very cold, windy day when Fernanda and I were just sort of talking about the wind because it was actually making us pretty unhappy. But you know, that quickly went from complaint to just sort of curiosity. We were like, what does the wind look like anyway? And you know, we started to wonder, like, if you had a map showing like the wind across the US, what would that look like? And I told Fernanda it would probably be pretty boring because the wind always just goes from west to east. And she was a little skeptical of that.
I'm from Brazil, so I didn't know any better. I was like, maybe that's what happens.
But then we started wondering. We were like, it can't always do exactly that, can it? And we embarked on this journey to try to find a whole lot of data, because we thought, okay, we could probably download, data from 1 or 2 weather stations, or you certainly could go to weather.com and get it for our area. But is there a way to get kind of a vector field of wind data from all over the US, or maybe all over the world? And it turns out that if you poke around long enough, you can find some data sets that have that form. And then the question really becomes, okay, how do you visualize that data? And I want to take you through the process here. We've heard a little bit about process today, and I think this is actually kind of interesting to look at. So I'm going to start by showing some data we found that was historical data for the whole world. Okay? And the first thing we did when we actually had this thing is, I'm sorry, I'm going to work in code here, but that's just the dirty, grubby world we live in here in the visualization headquarters. We said, okay, we're going to take a look at this thing and just decide for ourselves whether we got the data right, whether we're even parsing it correctly. So we drew this really ugly kind of green vector on black screen, takes you back to the 80s, picture of wind around the world. And we're like, okay, that's actually kind of believable. Like, surprisingly, you can sort of even see outlines of continents and stuff. The whole west to east theory looking a little dubious, but who can tell? This obviously was not going to be the final product. We really wanted to, have a dramatic and beautiful visualization, because at this point we were thinking of this really as an art project more than anything else. But luckily we had this killer idea for how to do it. We knew that there's like this whole scientific literature. It's very, very complicated. But we're like, what it comes down to is wind is just little particles moving around. So what we'll do is we'll have little particles moving around according to the wind, and it will look exactly like the wind. So we did that. We programmed something. And I mean, can you see any pattern there? Like any pattern? It's sort of weird, actually. Like, these things are actually moving in different directions at different speeds, and yet it just looks like static on a TV. So we're like, okay, maybe there's something wrong with, world data is particularly boring. Maybe if we find US data, it'll be better. We poked around, we got US data, tried again, hope, springs eternal. Well, you can see the outline of the US, that's cool, okay. So, all right, so that clearly wasn't gonna work. But we were not going to give up. We have plenty of excellent ideas, excellent ideas. And so we realized, okay, how about we do this? What if we have like a colored grid, like we're putting ink down on top of this vector field, and we're just going to let it flow according to the wind. That is going to give you like this wonderful and really deep sense of what's going on. So we decided to run this thing, and whoa, it's the United States, it's melting away. I went to Berkeley, stuff like this is sort of familiar to me. But it's really not quite as informative as you want, although sort of compelling in a passing a traffic accident kind of way. Okay, so what next? Well, we decided, all right, we need to do something that maybe shows the directionality of the wind a little bit better. So we came up with this idea of showing, sort of laying down strokes of paint, maybe in dramatic black and white paint, according to how things would flow along the wind. And it'll be really sophisticated. It's like the strokes will have different thicknesses according to how fast the wind is and so forth. So let's see what happens when we try that. Close your eyes if you're epileptic. It's going to be good when you hear that. And this gives you sort of the zebra skin rug view of wind across the US. It's actually a little bit of an improvement over the things we've seen. For one thing, it firmly demolishes the idea that the wind goes west to east. But it's also problematic in a lot of ways. Like, can you tell if the wind is going north to south or south to north in the middle of the country? You can't. Nonetheless, it's kind of interesting. And we even briefly toyed with the idea of just stopping here. But Fernando was like, it has to move. So we went back to the drawing board, thought a little bit more, and here's one of the other lessons I feel like I drew from this, is the value of working in code, because I'm about to show you a very small change. So we went back to this idea of little particles moving around, because really there was something conceptually compelling about this, even though it doesn't show you anything. And we just sort of thought about, is there any way to make it clearer what's going on, directionality? And we realized, okay, there's one very simple thing we can do. So let me describe this to you, and I'm going to get totally technical as I do this. This right here in the program is the main rendering loop. This is drawing what you're seeing up there. And like pretty much every piece of animation ever, it does two things. It draws a frame, and it does it has a thing where it's basically sets the color to black, and erases the background. So it erases whatever it drew last time. And then it draws the picture it's going to draw. And it just sits there doing that. It's like, erase the old thing, draw the new thing. Erase the old thing, draw the new thing. So here's the realization we had. What if we don't totally erase the old thing? What if we sort of draw with like almost a little bit transparent black, so you can see a little bit of the trail of those old particles? And in Java, in this version, it's just adding 3 characters to add that transparency. And let's see what happens when we do that, when we don't totally erase the old frame each time. Suddenly, you actually get something that's pretty easy to read. Like, it's very ugly and so forth, but you can realize, okay, from here on in, it's all going to be a matter of editing. Okay? Like, for one thing, it's very clear, okay, the wind is going from south to north in the center of the country. Okay, so that led eventually to a JavaScript version of this that you can see today. Hint.fm/wind. And this is today's wind. This is basically running off of a forecast that's extremely near term for the next hour or two. And you can see it's actually pretty dramatic. I mean, we've been seeing a lot of very interesting wind recently in the Midwest. But we can zoom over here. We can try to zoom in on Los Angeles. I'm not sure if will Pasadena be in here? I'm not entirely sure. Glendale, who knows? I'm not from Southern California. These things frighten and confuse me. What I like is, Massachusetts. We put all of our, the towns we've ever lived in this map. So this actually becomes an interesting artifact. Like, for one thing, there's something very hypnotic about this view. Like, even now, I'm in front of you, hundreds of people, and I should be paying attention, but I'm kind of just playing with this, and I could get hypnotized, so I've got to snap out of it. But it actually has, very emotional effects as well. So for example, if I go into this gallery, I can look at some of the past winds. And during Hurricane Sandy, for instance, it was actually this very creepy thing where, we know because we got a lot of email and we saw our server logs, a whole lot of the country was logging in to watch Hurricane Sandy make landfall. And this was, it's not often a visualization actually scares you, but this one did it. We were actually feeling slightly freaked out as we watched this. And I encourage you to sort of go and just look at this gallery and look at the amazing variety of what you see. Now, I'm going to close this for now and talk a little bit about the reaction to this, because this really did begin in a purely poetic mode, where Fernando and I were just thinking about wind and what it felt like. And we created this thing, and we deliberately even reduced some information just because we thought it didn't look poetic. Like, we could easily have colored it by temperature, which probably would have been pretty interesting. But we just didn't like that. We felt it distracted from the wind, and we wanted people to focus on that. So in no way was utility ever a goal with this. However, what we discovered is all sorts of people kind of latched onto it for all different kinds of utility. We saw people make YouTube videos out of this, and sometimes there were environmentalists who were trying to make a point about wind power, which is cool. That was actually one of the ways we were thinking about this as well. But other times there are people doing things I never would have thought of. For example, there are all these conspiracy theorists who believe that nefarious forces are sprinkling chemicals into the upper atmosphere. And they would do these videos saying, here's how we can use the wind map to track those. Very odd. Perhaps more interesting is we got a bunch of email from people. So some people just sort of liked it, but then told us it was valuable. But other people were very specific. People were like, I'm a farmer, and I use it to plan when to spray. And that began to actually freak us out a little bit. You're like, this is just running, the whole data conversion is happening every hour in a server and a little tiny study somewhere in Massachusetts. But we got scientists using it for bird migration. We've had people talk about butterfly migration. We had educators who were able to actually look at it, point out that this was sort of a classic tornado forming pattern, and then tornadoes happened the next day, which kind of impressed the kids. And enough people started using it, in fact, that we actually put this big disclaimer saying, please do not use the map or its data to fly a plane, sail a boat, or fight a wildfire. No art project we've ever done has ever carried a disclaimer. But interestingly enough, we got mail about 2 days later saying, yeah, we appreciate your disclaimer, but respect the power of the visualization and preventing wildfires, which was sort of surprising and interesting to us. So, I sort of want to end there and say this is one of the things that sort of impresses us. We view this presentation in many ways as a love poem to complexity, that in a whole lot of these cases we've shown you, we've really made no effort to, dumb things down. With Wikipedia, we just showed all the data. With Ripples, we didn't just put a little number saying, yeah, this thing was shared a lot, but we actually showed the full complexity of the spread. Here with wind, it's like, okay, we decided not to show temperature, but we showed data down to the 2-kilometer level. And people really embraced it. And so I think I'd leave you with that thought that complexity is actually perfectly fine. If your data is complex, it's fine for your visualization to be complex. Thank you very much. I think we have time for questions.
Thank you very much for the talk, especially for sharing the steps that you took along the way to get to the wind map. Very few people show the before and all the steps along the way. And so that truly was an open piece of sharing. I was wondering if I could ask a little more about it. When you showed each of the different drafts, it's clear that you were dissatisfied for one reason and chose to change certain parameters or optimize against others. And that with each map, you had to decide, well, given the data, what's the granularity? How big are our buckets going to be? And how sensitive are we going to allow our system to register? And do we want to use color? Is that valuable or not? Could you maybe look at one of the versions and explain what the thoughts were that helped guide your design process?
So it wasn't, it's hard to talk about any specific version and sort of retrace our steps back. One of the things I think we felt, it was this dissatisfaction with the gestalt of a lot of the things. So one of the things that we noticed right away from, say, the way traditional wind maps look is usually they are a static vector field, right? And what they do is that they will average the wind in any given point and give you a vector for that average. So in a way, they are simplifying things because they're giving you fewer points. One of the things that that does is that it makes the gestalt very, very hard, because I have to look at different parts of the map and remember, oh yeah, that is going up, that other thing is going down, that other thing is going sideways, but I don't get an overall view. And we felt like with this was the only version where we could look at the whole picture and see overall patterns, also see local patterns, but sort of take it all in at once. So if anything, I feel like that was our guiding principle, was when do you feel like you have an overall picture of what's happening in the entire country, at the same time that you feel you are getting the richness of the data. And like Martin said, at one point we just decided static was just not doing it. It was very easy to get lost.
Right. I'll also say that there's one sort of never fail indication to us that we've hit a point that is a good point for us. And that is when we get distracted from developing. Like, we tend to sit there and we're like trying things and tweaking things, and it's kind of fun. But the moment we hit this thing where it starts to work in some way, we'll just get distracted. We'll be like, oh, look at another thing on Google+. Okay, try another one. And work stops, you know? And that's probably the best sign of all, is that we have suddenly gotten distracted by the thing we're trying to build. Before then, it wasn't good enough to distract us. It hits that level, then we know it.
Thanks very much.
Hi, this is a very wonderful visualization of the wind, and I'm wondering if you've done it for any place else in the world or only the US?
So the US has really wonderful data. Thank you, US government. I actually, you know, we've spent a lot of time looking for data in other countries, and so far haven't found it. You know, because what you need is sort of very finely gridded data that is freely available and updated at least every few hours. And anyone who knows, not thinks that, oh, I think the UK might have that, but literally knows the URL of a page that would describe that data, we would love to hear from you. So.
Thank you.
So in addition to that, this technique has been used to show other kinds of data. So for instance, the flow of currents. So interestingly enough, NASA had put together a video showing the flow of currents around the same time the wind map came out, which was a really nice coincidence. Afterwards, so this is data from NOAA, and afterwards we got contacted from NOAA. Actually, we got email from friends saying, oh, thanks for sharing your technique with NOAA. We're like, really? When? And it turns out NOAA scientists had used the wind map, the technique, to show the flow of currents in the Great Lakes. And they did a really cool thing, which is they showed the flow of currents in the lakes at different depths. So you had the average depth, you had the lowest depth, and you had the surface of the lakes. And it's it's fascinating because I had no idea, but the surface is completely different from the bottom of the lakes. And then we had a marine biologist who got in touch with us and wanted to visualize the currents around the US. And he did that in real time. So that was one nice
So one thing that I'm wondering is how much should we be training undergrads and graduate students in science to do this kind of thing, and how much should we instead just be hiring people who are already experts? You know, this is beautiful, and it's not necessarily something that, you know, an astronomy grad student is going to be trying to produce.
You know, my hope would be that people should be trained in this, I think, because it's, you know, every bit of training, and it's like any kind of education where, like, the first year can do, like, a huge amount of good, where, you know, you learn a lot very, very quickly. And I think I would compare it to writing, where I would say learning to write well is often said to help you think well. I think learning to present things visually also is a way of learning to think well. So I think it's something very important and is a kind of literacy akin to writing. Now, as with writing, it's like there's always going to be people who make a profession of it versus people who just, you know, make use of it to describe their results. And one respects, you know, those different choices. But I think it's a kind of literacy that I see as being increasingly important and really not too expensive to obtain.
Mm-hmm.
Your work's amazing. I've actually been following you on Mini Eyes for like years. It's really the bomb. One thing, so I have a few questions really straight up. Why Java instead of processing? And secondly, you need to do this map with financial transactions. So do this with Google Wallet. I want to see the flow of money around the world.
Interesting idea.
And you could do it because you know the address of the origin and the address of the recipient. So you have like long connections instead of like short ones.
Interesting idea. To answer the processing Java question, the answer is largely because I think we both started using Java before processing existed. And so once you start using Java and you have your own libraries built up, it's fine. You know, at this point, actually, most of the graphical work we do is actually in JavaScript. So you saw this Java was sort of a little bit what we used to prototype this, but the map on the web is actually JavaScript. But yeah, processing is great. It's just that, you know, I'm a fossil, so.
Yeah, we're older than that.
Do you have any suggestions for like modern text-based things? So it's something I've always wanted to do. I always want to apply like the kinds of analyses you've done to political speech or to closed captioning data and things like that. So you can say, oh, you know, how different are, say, the speech patterns of, say, Fox News versus, say, CNN, something like that. And you could say, oh, you know, and so I guess you'd want to compare I guess your two graphs. So I guess you have like these phrase trees here, and I guess you want to compare two phrase trees, something like that.
So there is a version of the word tree that is in JavaScript, and it's freely available. It's not Many Eyes. Do you remember the name of the creator of?
Yeah, it's Jason Davies, I think.
I think so.
Yeah.
Yeah. So that's one place to go, and then there are things like Wordle, which is completely, you know, free, and it's not a word tree. It's a word cloud.
But yeah, I think comparisons
is
a really
yeah.
interesting question, and you could have an InfoVis paper. So maybe you should do it.
Take a look at Neil Formix. He does a lot of comparison of texts. He has a blog where he creates visualizations that compare different pieces of text.
Thank you.
So we've been told this is the
quick
last
question. Are these surface winds which you display, or can you add a third dimension in terms of wind at altitudes?
Yes, these are surface winds up to 10 meters.
But you could add the third dimension, obviously.
Yes, if we had the data, yes.
Great. Thank you very much.
Thank you.